So now we're going to get more in depth with slope. So slope is the rise over run of a line. So it's the change in y over the change in x. That's our slope, which sometimes it's also called a. It's whatever the number is in front of the x when it's in slope-intercept form. And just a quick refresher, your slope-intercept form is y is equal to your slope times the x plus your y-intercept. Now the formula for this, you take, if you had 2 points, we'll call them x1, y1, x2, y2. So if you have 2 points, you take the y2 minus the y1, that goes in your numerator, and then you find the change in x by taking x2 minus x1. Now, when we look at slope, we can have different kinds of slope that show the direction of the tilt of the line. The number of the slope tells us how steep the slope is, and the sign next in front of it tells us if it's increasing or decreasing. So if you had a slope that's, say, +3, if you have a positive slope, then it's going to go up left to right when you look at it. You read graphs just like a book. You look at it left to right. So if I look at it left to right and it's going up, that's a positive slope, or it indicates that the values on the line are increasing. Now, if you had a negative slope, say it was -2, then that means when you look at it and read it left to right, it's going to be going down. So the values on the line are going to be decreasing. Now, we have special slopes, special cases, where the slope is 0. That's when you have a horizontal line. And then when you have a vertical line, that's when you have an undefined slope. When you have a 0 slope, that's when your numerator is equal to 0. 0/3, 0/7, it doesn't matter what that bottom number is as long as it's not 0, because that would be undefined. But if you have 0 over any other number other than 0, when you divide, that's going to give you a 0. So that's what causes the slope to be a 0. So that's when the change in y is equal to 0. Now, when you have an undefined slope, that's when the denominator is equal to 0. And that is undefined. So if you had the change in x is equal to 0, that means you could have some number, let's say it's 5/0, and that's undefined. So these are your special cases. But most of what we're going to be looking at is going to be positive and negative slope. For this one, we're going to identify the sign of the slope and the steepness of the slope. The steepness is the number, and then the sign is what's in front of that number, whether it's a positive or a negative. So there's a couple different ways that you can do this. You can do this by looking at the graph, and you can do this by using the formula. So when you look at the graph, you're just looking from one point on the graph to another point, and it doesn't matter which 2 points you pick. It's always going to be the same, but you find the change in y and divide that by the change in x. So looking at this graph, this distance from here to here, that's my change in y. This is where y is equal to 3. And in this point, y is equal to 7. So the change is going to be 4. So the change in y is equal to 4. Now let's look at the change in x. The change in x is the horizontal change. So from this point to this point, here my x is 1, and for this point, my x is 4. So my change in x from 1 to 4 is 3. So my slope, by looking at the graph, is going to be the change in y over the change in x, which is equal to 4/3. And then you want to double check the direction that it's tilted. When I look at this graph and I look at it left to right and I trace this, it goes up left to right. So this means it's a positive slope. That means it's increasing. Now, if we do it using the formula, remember that's y2 minus y1 over x2 minus x1. So if we use the points that are on there, 1, 3, and 4, 7, I'll label this as x1, y1, x2, y2. So if I take the change in y, which is y2 minus y1, so that's 7 minus 3, which is 4, and then I take the change in x, that's x2 minus x1, which is 4 minus 1, it's 3, I get the same thing. Now, does it matter which point you label as 1 and 2? It absolutely does not. Watch what happens. If I switch the points and call for 7 x1 and y1, and I call 1, 3 x2 and y2, we're going to get the same value. So let's do the change in y over the change in x. So this time we're taking 3 minus 7 because we're doing y2 minus y1. So 3 minus 7, that's a negative 4. And then I take 1 minus 4, that's a negative 3. And a negative divided by a negative is a positive. So I get the same thing. So it doesn't matter which point you label as 1 and 2 as long as you're consistent. If you call this 1 x2, then this 3 has to be y2. You can't mix the 1s and the 2s, but as long as you're consistent with that, your answer will be the same.